Okay, in this video we're going to start section 6.3, trigonometric functions of any angle, and what we're going to concentrate on in this video is evaluating the trig functions of any angle. In the previous section we were talking just about right triangle trigonometry, and we kept our conversation in the first quadrant. So here, again, what we did in the past, all our angles were here in the first quadrant. The big ones we looked at, a 30-degree angle, 45-degree angle, and then our 60. Those are the biggies, 30, 45, 60. But all our values were always here in the first quadrant. Now we're going to swing out and go into any quadrant that we want and be able to find and evaluate these trig functions of any angle. And one thing we're going to get to will be reference angles. And that's just the reference angles will have the same value as the angles that we already know, but the sign might be different. Just as a case in point here, if I'm looking here at an angle in the second quadrant and I want to evaluate the sine of this this angle here. Well, if I look at its reference angle, and we'll see that is just this little angle that the quickest way back to the x-axis, maybe this is a 30-degree angle, a reference angle. So what I can do is in my mind, swing this angle, this point, around to the first quadrant. If this is a 30-degree angle and my point's out here at x comma y, and that would be a negative x value because we're here on the left side of the y-axis. So that would be the point. Would go to the x-axis, or would find our x coordinate would be a negative x coordinate. Our y value would be positive. And if this is a 30-degree angle, we can just swing that around to the first quadrant. Here's another 30-degree angle. And if we go out the same distance, this would be positive x comma y. The only difference between these points is we have one of them has a negative value. And of course that'll change the value of our trig function, maybe from negative to positive or positive to negative. But now we're going to expand what we did in the first quadrant all the way around, and we can easily find a reference angle and figure out the value of the trig functions based on an angle similar to it in the first quadrant. So it says here in the previous section, the definitions of the trig functions were restricted to acute angles. And again, and that kept us in the first quadrant. In this section, the definitions will be extended to cover any angles. If theta is an acute angle, these definitions coincide with those given from previous sections. So our new definitions here for any angles are going to be: let theta be an angle in standard position. Again, standard position, our initial side is on the positive x-axis, and then our angle opens up counterclockwise for positive angles. So theta is an angle in standard position with x comma y is a point on the terminal side. So somewhere out here in the Cartesian plane we're going to have a point, and that's an x comma y coordinate. That point is on our terminal side of angle theta, and r is going to be x squared plus y squared, that quantity square rooted, which, if you notice, that's just the Pythagorean theorem. If I come here to this little drawing and I drop a line straight down, so I make a right angle here with the x-axis, I do have my a right triangle now. The length of this side is x, the same as our x coordinate, and then when we rise up to our y coordinate, this side is y. So this side we're now going to consider r. This is sort of the hypotenuse of this right triangle. And if we plug that into the Pythagorean theorem, we would get x squared plus y squared equals r squared. And if we square rooted to find the value of r itself, it would be x squared plus y squared under a radical. And with the stipulation that this length is not going to be equal to 0. When we look at angles this way, we know the sine of the angle is going to be y over r. Or simply take this y coordinate and put it over the length of that side r. Cosine is the x coordinate over r. Tangent will be y divided by x, given that x is not equal to 0. For cotan, we turn that upside down, x divided by y, as long as y isn't 0. Secant is r divided by x, again with x not equal to 0, and cosecant r divided by y, given that y is not equal to 0. Because r, this quantity, x squared plus y squared under the radical, cannot be 0, it follows that the sine and cosine functions are defined for any real value of theta. However, if x is 0, the tangent and secants of this angle will be undefined. Again, if x is 0 right here or here, we would have a divide by 0 scenario, so those functions will be undefined at that angle value. For example, tangent of 90 degrees is undefined. Similarly, if y equals 0, the cotan and cosecant functions will be undefined. And this is a good place. We're going to start to associate. Remember, in the coordinate plane, we have an x comma y coordinate. It's going to help in the long run if we start thinking right now. We associate the x coordinate with the cosine function. And we're going to associate the y coordinate with the sine function. So, let's start working on this right now. X is going to be paired up with the cosine value and the y coordinate with the sine value. So here in example 1, we're just going to apply this new definition of these angles. It says, let negative 3, 4 be a point on the terminal side of angle theta. Find the sine and cosine and tangents of theta. So here's our angle opening up. There's theta, and the point negative 3, 4 is on that terminal side. So to apply these new definitions, we need three things: x, y, and r. We have x. X is given in the problem. That's negative 3. Y is also given. That's 4. We need r. And again, by its definition, r is x squared plus y squared under the radical. Again, if we come back to this picture, we can see we can drop down here and make a right angle. The length of this side is 3. The height here is 4. So we're going to just apply the Pythagorean theorem. A squared plus b squared equals c squared. And in the context of this problem, r is the square root of x squared plus y squared. So under the radical, x squared is negative 3 squared, or 9. Y is 4, so y squared, 4 squared is 16. Under that radical, we have 9 plus 16, which is 25. And that works out to be a perfect square. So r, when we take the square root of 25, is 5. So here we have x, y, and now we have our r value. And now it's going to be a piece of cake to find sine and cosine and tangent of theta. Because we'll just pop back here, and we know that sine is y over r, cosine is x over r, and tangent is y divided by x. So here, and I'll write it out since this is all new, the sine of angle theta is y over r. Well, our y value is 4, our r is 5, there we go, 4/5. And if we tie this to sort of the definitions that we had previously, if I'm looking at this angle down here in the triangle, sine is opposite over hypotenuse. Well, opposite this angle is our side that is height 4. We found the hypotenuse to be 5. Sine is 4/5. Cosine of angle theta. Cosine of theta by these definitions are x divided by r. X is negative 3. R is 5. Cosine negative 3/5. And finally, tangent. The tangent of angle theta is y divided by x. So we just take the y coordinate 4 over the x coordinate 3, which is negative 4/3. There we go. The signs of the trig functions in the four quadrants can be determined from the definitions of the functions. For instance, because cosine is x divided by r, it follows that cosine is positive whenever x is positive, which is in quadrants 1 and 4. Remember, r is always positive. In a similar manner, we can verify the results shown in the figure. Again, I'll come back and say that it's a good time to start associating. We have our x comma y. We want to start associating the x coordinate with cosine functions and the y coordinate with the sine function. So here are the four quadrants, and let's just talk about sine. Sine is equivalent to the y value. Where in the four quadrants is y positive? Well, that's up here on this positive part of the y-axis. Y is positive, so sine is positive in the same quadrants. So sine is positive in quadrant 2. Sine is also positive in quadrant 1 because the y values are positive. The x values deal with cosine. Where are the x values positive? Well, the x values are positive on this part of the x-axis. So if the x values are positive here, so are the cosine values. Cosine is positive in quadrant 1, and below that, cosine is positive in quadrant 4. And to find tangent, remember tangent is sine divided by cosine. So if we think here in quadrant 1, sine and cosine are both positive. Tangent is sine divided by cos, or in this case it'd be positive divided by positive. Tangent is positive. Down here in quadrant 3, both the x values and y values are negative. So sine and cos are both negative. Negative divided by negative is positive. So down here tangent is positive in quadrant 3. In the other quadrants, in quadrants 2 and 4, you have a positive sign and a negative cos, or a negative sign and a positive cos. Because those signs are different, tan again is sine divided by cos. In quadrant 2 we have a positive sign divided by a negative cosine. Positive divided by negative is negative. Tan is negative in quadrant 2, and for the same reason in quadrant 4. We have a negative sign and a positive cosine. Negative divided by positive is always a negative. So there we can quickly determine what trig functions are positive or negative in which quadrants. And when we start to expand this thinking to our angles measured in radians, here in the first quadrant, all angles are between 0 and a half pi. Sine is positive, cosine is positive, tangent is positive. In the second quadrant, all radian measured angles between a half pi and 1 pi. In this quadrant, our sines are positive, cosine values are negative, and then tangent values are also negative. Down here in the third quadrant, all angles between pi and a pi and a half. Down in this quadrant, quadrant 3, sine is negative, cosine is negative, and tangent is positive. And the last quadrant, all angles between 1.5 pi radians and 2 pi radians, our sine values are negative, our cosine values are positive, and tan is also negative. And let's take a look here at example 2. We were given a little information. It says, given that tangent is negative 5/4 and cosine is positive, find sine and secant of that same angle. So let's see here. We have cosine is positive, and if we think to the coordinate axes here, again cosine is the same as our x-coordinate. Where are x values positive? Well, x values are positive along this side, so we know right now we're either in quadrant 1 or quadrant 4. Our other bit of given information tells us that tangent is negative. Well, in quadrant 1, sine and cosine are positive, and so is tangent. Here in quadrant 4, we have our cosines are positive, our sines are negative. So here we would have negative tangent values. So it looks like in this problem, we are in quadrant 4. We are in quadrant 4. And let's see here, we're also given, we know that tangent of theta is negative 5/4. Tangent is also y divided by x. So we know that we have a y-coordinate and an x-coordinate. Which of these does the negative sign go with, though? Do we have a negative 5 up with the y, or is it a negative 4x? Well, again, if we go back here, we already figured out we are in quadrant 4. We have positive x values and negative y values. So we know that this negative is going to go with that numerator. So we're starting to piece together the things we need to solve this problem. We know that our x value is the positive 4, our y value is the negative 5. Now that we're sure of x and y, we can find r. Because remember, r is the square root of x squared plus y squared. Well, x squared, 4 squared is 16, plus y squared, negative 5 squared is positive 25. And if we add those up, we get 41 under the radical, square root 41. It's not a perfect square. We can't simplify it at all. We could get a decimal equivalent to that, but it's more precise to use radicals. Using these gives us our exact, precise figures. So we know that r is the root of 41. So if we go back to the original problem, it does say they want us to find sine and secant. So I think we have everything that we're going to need. So sine, by these new definitions, the sine of this angle theta is y divided by r. which is -5 divided by the root of 41. And because we have a radical in the denominator, let's rationalize. We'll multiply through by the root of 41. So our sine value is -5 root 41 divided by root 41, or excuse me, divided by 41. Now always check here, 5 and 41, that's a fraction. Can it be reduced? Not in this case. So this is going to be our final answer. There is the sine of that angle that we were given. Now let's flip to secant. They also asked us to find the secant of the same angle. Well, the secant of theta by these new definitions is r divided by x. Well, we have r, that's the square root of 41, and that's up top, so we don't have to worry about rationalizing. X is 4. The root of 41 over 4, and we're done. In example 3, find the trig functions of the quadrant angles. Now remember, we're talking about the axes themselves. Then these do not exist in quadrants, they're sort of in between quadrants. Evaluate the cosine and tangent functions of these 4 angles: 0, half pi, 1 pi, and 3/2 pi. So we are going to do what we're asked to find: cosine and tangent functions. Okay, so for each of these, when we do each angle, we're going to have different x and y values, but they're easy. We can pull those right off here. Remember, it's always x comma y. We are also going to need an r, the length of that r, that sort of the hypotenuse of the triangle. And for each of these, it's going to be pretty simple. All the way around here, we have -1s, 1s, and 0s. And it doesn't matter if we plug in for the x value a 1 or a -1. When we square it, we're going to get a 1. And the other coordinate's going to be a 0. 1 plus 0 is 1, and the square root of 1 is 1. So for all of these, r is going to be equal to 1. So I'll just write that down here in the corner. R is equal to 1, and then depending on what angle we're working with, we'll pick the 1 and the 0 for x and y, or the -1 and 0. So first they wanted us to find cosine. The cosine of the angle is equal to x over r. So for the first angle, cosine of 0. Well, here at angle 0, our x value is 1, our r value is 1. So that is has a value of 1. Cosine of a half pi, pi over 2. That's still x over r, but now we're up here. X is 0, r is still 1. 0 divided by 1 is fine, that's 0. Next quadrant angle is 1 pi. The cosine of pi, and that's still x over r. Here at pi, it's -1 over 1. And we divide that and get -1. And then 3/2 pi. Cosine of 3/2 pi radians. Now we're down here, so our x value is 0 again, our r value is 1, and that is 0. So there are the values of cosine for the 4 quadrant angles: 1, 0, -1, 0. Now we're going to do the same thing with tangent. So the tangent of an angle is y over x. So here we're not even going to need this value of r, we're just looking at the x and y coordinates. We're going to make a fraction, y on top, x on the bottom. So the tangent of 0. Well, here at 0 we have a y value of 0, an x value of 1. 0 divided by 1 is 0. Tangent of 1/2 pi radians. So now we're up here at this quadrant angle, our y value is 1, and we are dividing that by x, 0, so that's going to be undefined. Tangent of the next quadrant angle, pi radians. So now we're right here, and our y value is 0, our x value is -1. 0 divided by a -1 is 0. And finally, tangent of 3/2 pi radians. So we're down here in this, between the third and the fourth quadrant. Our y value is 0, or our y value is -1. Our x value is 0. We cannot divide by 0. So here again we have an undefined. That's it for this video. Here are a few problems, to practice what we just learned. For the huddle problems, pause the video here, give the problems a try, turn the video back on, and see how you did. Okay, let's check out these huddle problems here, these practice problems. I'll clear a little room. In the first one, it does say determine the exact values of the 6 trig functions of angle theta. And let's just look at the first 3, sine, cosine, and tangent, because we can always just flip those over to get the other 3. Here in letter A, we got our angles in the first quadrant, theta, and we have our x and y values. Our x value is 3, our x value is 4, our y value is 3, and r. Remember, r is the square root of x squared plus y squared. So x squared will be 16, y squared will be 9, and those add up to 25. The square root of 25 is 5. So we have our 3, 4, 5 Pythagorean triple right triangle. And if we want to find our trig functions for that, remember sine is y over r, and in that case it's 3/5. Sine of theta equals 3/5. The cosine of theta, that's just our x value, 4 over r is 5. And then tangent, the tangent of angle theta is 3 over 4. Again, if we want cosecant, flip sine over. If we want cotan, flip tan over. If we want secant, flip over cosine. And here in part B, the only difference now, we're out into the second quadrant, so we do have a negative value here. Our x-coordinate is -8, our y-coordinate is 15, and we can find r by x squared plus y squared under the square root. And -8 squared is 64, 15 squared is 225, and if we add those up we get 289. And that is a perfect square. The square root of 289 is 17. So our r is 17. And now, just like we did for the first one, we'll set up our trig functions. Sine of theta here will be 15 over 17, y over r. Cosine theta will be -8 over 17. And tangent of theta is -15 over 8. And here again, in the first example, we were in first quadrant. In part B, we were in the second quadrant. In part A, then, first quadrant, everything's positive, sine, cosine, and tangent. Here in part B, we've swung our angle into the second quadrant, which makes our x value negative. That's going to change our cosine value to a negative value. And that also affects tangent, because tangent is sine divided by cosine. A positive divided by a negative will give a negative output. And again, if we wanted to flip these 3 trig functions over, we would have our corresponding, cosecant, secant, and cotangent. The second problem here, it says find the values of the 6 trig functions of theta with the given constraint. So we have this constraint that sine is positive. Sine is greater than 0. And remember, sine is paired up with the y-coordinate. So this is also telling us we're in areas where y values are positive. Well, where is our positive y-axis? That's right here. So we know by this constraint we are somewhere in quadrant 1 or quadrant 2. Let's take a little look further at what they've given us here in our function value. We know the tangent of the angle is -15 over 8. And remember, tangent is the same thing as y over x. So let's hear this negative. It either goes with the 15 or it goes with the 8. And let's see. We know that sine is positive and our tangent value is negative. Tangent is negative. We know everything's positive in the first quadrant. Tangent is negative in the second quadrant. So that's going to give us a clue that the negative sign is going to go with the 8. Because, here in the second quadrant, our x values are negative. So using that information, now we know that x is -8. And we know that y is positive 15. And well, this looks a lot like this problem we have up here. Our x value was -8, our y value was 15. Use the same process to solve for r, and we get r is positive 17. And then we set up sine, cosine, and tangent. And again, these are going to come out just like we found above. The sine of theta is going to be 15 over 17. The cosine of theta, negative 8 over 17. And the tangent of theta, negative 15/8. So we've got, again, use the constraint. Maybe we'll figure out, narrow down what quadrant we're in to at least 2 of them, and then go back to the given function value. Check the sign of that. The sign is going to be the key. And the last one here, it says evaluate the trig function of the quadrant angle. So let's see here. Here's our xy axes, and it says the sine of pi. Well, pi radians, remember a complete lap around the unit or the circle is 2 pi. Half a circle is pi radians. So this is our pi radian angle. And let's just think about our right on the axes we have points. This would be a positive 1 on the x, a 0 y. This would be 0 on the x-axis, positive 1 on the y-axis. Over here we would have negative 1, 0. And just to finish it off, why not? We got 0, comma, negative 1. Well, we're looking for the sine of this angle. And remember, sine is y over r. So here, you know, our radius would sort of be 1, and our y value is 0. So 0 divided by 1 is 0. The sine of pi radians is 0.